Okay, now for the work, power and energy, work, energy, and power. Now for the work, application of work, energy, power occur in almost all the areas of science. In our everyday living, these have many shades and meaning, but for physics, they must begin with an accurate and limited meaning. Now, for the work, for the work and energy, okay, do we have the same, always remember the work and energy have the same units and formula can be used vice versa. Okay, always remember the work and energy have the same unit and you can use the formula vice versa in finding what if the requirement is to find for the energy but the given is under the work, you can use the formula of the work in finding for the energy. Now, work can be done upon the object if the force acts upon it cause a displacement of the object. It can also define as the transfer of energy. There are three keywords for the work, that is three key. Okay. There are three keywords for the work, that is force, displacement, and the cause. Now, in order for a force to be eligible as having done work on an object, there must be a displacement and the force that causes the displacement. Now, for the energy, energy came from the ancient Greek word that means activity or operation. It's an indirectly observed quantity. It is often understood as the ability a physical system has to do work on other physical systems. Okay. While power is the rate in which the energy is transferred, used, or transformed. The quantity that has to do with the rate at which a certain amount of work is done is known. Now, for the work is the product of the magnitude displacement and the component of the force in the direction displacement. This one, it is also an example. A scalar quantity with magnitude only. Now, given body, applied force, okay, of course, the reaction of the body, it will move horizontally. Therefore, this one is the displacement now. Okay. In finding for the work, we have the work is equal to F times S. Force multiplied by the parallel displacement. Okay. What if the given force, given body, The force is under the polar coordinates. Of course, this one is your angle theta. Okay, first you have to look for F times X. Okay, the reaction of your body. This one is the displacement. Now, the work for this given figure, we have the work is equal to Fx times S. Remember that your Fx is under the Cartesian coordinate. Therefore, that is F cosine theta times S. Now, always remember, if the force is in the same direction as the displacement, the work is positive. If the force is in the opposite direction, okay, if F is in the opposite direction as the displacement, the work is negative. If kailan ba when is your work can be negative? Instead of using the force, you're going to use the frictional force. Okay, the frictional force is lying always opposite on the applied force. This one is the frictional force. if if F is parallel to the displacement, the work is equal to F times S, or work is equal to F cosine theta times S. If force is perpendicular to the displacement, the work is equal to 0. Okay, in the given figure, here, the normal force is this. You have the normal force. This one is the normal force, and this one is the weight. Okay, if the force is perpendicular to the displacement, the work is 0. What if the requirement is to find for the work of your weight? Of course, the work for the weight is equal to 0. The reason is the weight is perpendicular to your displacement. And the normal force, the work of the normal force is equal to 0 also. Why? Because the normal force is perpendicular to the displacement. Okay. Work of the force is equal to F cosine theta times S according to this figure. And for this figure, your work is equal to F times S. But for the work of frictional force, therefore that is equal to negative F times S. Work of the weight is equal to 0, and the work for the normal force is equal to 0. Now, what are the units for the work? Under the SI, you have the joule. When you say joule, That is Newton meter. For the CGS, you have 9 centimeter, which is also ergs. And then for the English, we have foot-pounds or BTU. 1 BTU is equal to 778 foot-pounds. Okay, example. Number 1, a box weighing 45 pounds is lifted to a height of 5 feet above the ground. What is its work at that point? Okay, now we have the given weight, which is equal to 45 pounds. And then lifted height is 5 feet. And then the required is the work. Okay. Remember that this one, the object is being lifted. Okay. The force, weight, equal to 45 pounds. Of course, from the ground, tapos 5 feet ang inangat. With the height. Summation of forces y equal to 0, where F minus the weight is equal to 0. Force is equal to weight, where the force is also equal to 45 pounds. Okay, therefore, the work solution, the work is equal to F times S, which is the same as the height. Therefore, we have 45 pounds multiplied by 5 feet is equal to 225 foot-pounds. Okay, number 2. How much work is done in joules when a mass of 4.5 kilogram is raised to a height of 4.5 meters. Okay, given we have the mass of 4.5 kilogram, the height, and the displacement, that is 4.5 meters. The requirement is the work in joule. Okay, solution. Okay, in finding for the weight is equal to mass times the gravity. Therefore, the mass is equal to 4.5 kilogram, and then the gravity of 9.8 meter per second squared. Okay. Then, again, the requirement for the work. Therefore, since the object is hanging, okay, therefore the force is the same as your weight, which is equal to 4.5 kilogram times 9.8 meter per second squared. Now, for the work, we have F times S, which is equal to 4.5 kilogram times 9.8 meter per second squared, multiplied by the height of 4.5 meters. Okay, the work now is equal to 198.45 joule. Okay, another example. A luggage is dragged 50 meters along a floor by a force of 15 newtons, inclined at an angle of 45 degrees to the floor. How much work is done on the luggage? Okay. Okay, therefore, example, this one is your luggage. Okay, 50 meters along the floor, where S is equal to 50 meters. Then, 15 newtons inclined at an angle of 45 degrees. 15 newtons. Then, 45 degrees to the floor. How much work? Okay, therefore, we have your Fx. The work here is equal to Fx times S, which is equal to F cosine 45 degrees times S, where the work is equal to 15 newtons cosine 45 degrees multiplied by 50 meters, which is equal to 530.33 joules. Now, another example for the number 4, the coefficient of kinetic friction. Okay. The coefficient of kinetic friction between a 20 kilogram box and the floor is 0.4. How much work does a pulling force do on the box in pulling it? 8.0 meter across the floor at a constant speed. The pulling force is directed 37 degrees above the horizontal. Now, let us have a background about the friction. Okay. Before we solve for this one. Now, for the friction, it is the resistance to movement of a body over another body. The word comes from the Latin verb fricare, which means to rub. to rub. Okay, friction is considered the evil of all motion. No matter which direction something moves in, friction pulls it the other way. Move something left, friction pulls it to the right. Now, for the friction, it is a tangential force on a body which opposes any tendency for its surface to move relative to another surface. Okay, we have types of friction, kinetic or sliding friction. When you say kinetic or sliding friction, kinetic or sliding friction, a tangential force between uh, two surfaces when one body is sliding over another. Okay, what are the properties of this friction? The frictional force is parallel to the surface sliding over one another. The frictional force is proportional to the force which is normal or perpendicular to the surface and which presses them together. The frictional force is roughly independent of the speed of sliding, provided that the resulting heat does not alter the condition of the surfaces. The frictional force depends upon the nature of the substance in contact and the condition of the surface on polish, roughness, grain, or wetness. Now, for the coefficient of friction, okay, or sliding friction, that is mu k. The symbol is mu k. That is equal to the frictional force over the normal force. Frictional force over the normal force. Since the unit for the frictional force and the normal force are both the same, therefore the coefficient of friction is unitless. Now, for the static friction, difference naman, when you say static friction, tangential force between two surfaces when one is not sliding over another. Okay. When you say static friction. When you say static friction, tangential force between two surfaces when one is not sliding over another. Static friction acts to keep the object from moving. If F increases, so that the static frictional force. If the force decreases, of course, the static frictional force also decreases. The same formula as the coefficient of friction. Instead, it is mu s is equal to Fs for the static frictional force over the normal force. Okay. Now, let us try to solve this one using the formula. We have the given mu. Okay, let us first draw the figure. Given S, which is equal to 8 meters. Okay. The given mass of the box is 20 kilograms. And mu k, coefficient of frictional force, is 0.4. Okay. Then S is 8.0 meter. And then the pulling force theta is equal to 37 degrees. Okay, since there's a given mu k, coefficient of frictional force, of course, there will be a kinetic frictional force. And then, with the condition that the pulling force is directed 37 degrees above the horizontal. Therefore, we have here your force, 37 degrees. Okay, we have here your Fx, 37 degrees. We cannot easily say that your work is equal to Fx times S. Since we have here your Fk, we cannot disregard your friction here. Okay, all you have to do is to look for your Fk. Using this, given is the mass of the object. Of course, you have the weight here. You have the weight. Then you have the normal force. Summation of forces y equal to 0. Your normal minus the weight is equal to 0. Weight is equal to normal or normal is equal to weight, where normal now is equal to normal force is equal to weight, which is mass multiplied by the gravity. Mass times the gravity, we have the mass of 20 kilogram times 9.8 meter per second squared. The normal now is equal to 20 times 9.8 meter per second squared. Now, from the formula of your mu k is equal to Fk over the normal. Fk is equal to mu k times the normal force. Coefficient of friction is 0.4. 0.4 times the normal of 20 times 20 kilogram. 20 kilogram times 9.8 meter per second squared. Now, this one is summation of Fy. Now, we have summation of forces at x equal to 0. What are the forces acting on the x-axis? You have your Fx and Fk. Fx minus F, going to the right positive, going to the left negative, is equal to 0, where your Fx is equal to the kinetic frictional force, okay, which is your Fk is equal to 0.4 times 20 kilogram times 9.8 meter per second squared. But your Fx is also equal to F cosine 37 degrees, equal to 0.4 times 20 kilogram times 9.8 meter per second squared. Okay, therefore, the work now is equal to F times S. But your F, from the given equation here, you have 0.4 equal to 0.4 times 20 kilogram times 9.8 meter per second squared divided by cosine 37 degrees. Cosine 37 degrees. For work now, substitute, you have 0.4 times 20 kilogram times 9.8 meter per second squared over cosine 37 degrees times S, which is S is 8 meters times 8.0 meters. Okay. The normal here, meron pa pala tayo, we forgot you have the value of your Fy. Instead of this one, you have 2n minus W plus Fy. Okay. plus Fy equal to 0. Therefore, the normal minus Fy equal to minus 8. There's a missing. Therefore, the weight minus okay, we have also your Fy here. Therefore, normal equal to weight minus Fy. The normal Fy. Normal is equal to weight mass times gravity 20 kilogram times 9.8 meter per second squared. Fy is negative. F sine 37 degrees. Sine 37 degrees. Therefore, summation. Okay, this one is Fx. What is the value of your Fk? Uk and minus F sine 37 degrees. Okay, summation Fk. Okay, again. Okay, this one is F. Okay. Okay, but your Fk is F sine 37 degrees. Okay, therefore we have F cosine 37 degrees. This one is Fx equal to Fk, but your Fk is equal to 0.4. Okay, 0.4 mu k normal. Okay, 0.4 times 20 kilogram times 9.8 meter per second squared minus F sine 37 degrees. Simplify, transpose natin, transpose your F sine 37 degrees to the right side, to the left side. Okay, therefore, before we proceed to this one, okay, therefore we have F cosine 37, F cosine 37 degrees transpose plus F sine 37 degrees equal to 0.4 times 20 kilogram times 9.8 meter per second squared. Common factor is F, therefore that is cosine 37 degrees plus sine 37 degrees equal to 0.4 times 20 kilogram times 9.8 meter per second squared, where work is equal to F times S, where F now is equal to 0.4 times 20 kilogram times 9.8 meter per second squared divided by cosine 37 degrees plus sine 37 degrees. Okay. Okay, therefore that is 0.4 Ang 0.4 ay para sa lahat ng normal. Di ay, be careful ating i-check nyo maigi. May 0.4 pa. Kasi ang because your mu k times the normal is 20 kilogram times 9.8 f sine 37 degrees. Therefore, you have to distribute your 0.4 times 20 times 9.8 minus 0.4 times f sine 37 degrees. Therefore, we have 0.4 pa and 0.4, 0.4, 0.4. Be careful with that. Plus 0.4. Okay. Work is equal to 0.4 times 20 kilogram times 9.8 meter per second squared divided by cosine 37 degrees plus 0.4 sine 37 degrees times S, which is 8 meters. Resume recording. It should be F cosine theta times S. Kasi F lang tong value to. Kaya dapat meron pa rin siyang cosine 37 degrees. And times cosine 37 degrees times 8 meters. Oh, yan. Work is 481.93 joules. Number 4, 5. Number 5. A block. 30 degrees incline under the action of certain forces which are shown in figure. F1 is horizontal and of magnitude 40 newtons. F2 is normal to the plane and of magnitude 20 newtons. While F3 is parallel to the plane and of magnitude 30 newtons. Determine the work done by each force as the block Point of applications of each force moves 80 centimeter up the incline. A given figure in black. This one is the black. You have your F2, F3, parang something, and then okay. This one is F2, F1, F1, 30 degrees. That is 30 degrees. You have your F1 cosine 30 degrees. Okay, now for the work, we have the work for F1, which is equal to F1 cosine 30 degrees times S, where your F1 is equal to 40 newtons, multiplied by cosine 30 degrees, S of 0.8 meters, 0.8 meter. Okay, therefore, your work at F1 is equal to 28 joules. While for the work at F2, which is equal to 0. Why? Because your F2 is perpendicular with the displacement. Now, for the work at F3, therefore that is equal to, F3 is equal to 30 newtons. F3, 30 newtons. Okay, therefore, that is 30 newtons multiplied by 0.8 meter. Therefore, your work at F3 is 24 joules.